Welcome to LabMinutes.com and our lab video series on Cisco ASA 1000V. You can find a complete list of ASA 1000V video on our website by clicking on the link above and sign up for our newsletters to receive the latest video updates. Cisco ASA 1000V has a site-to-site VPN feature that allows your virtual data center to be securely accessed. You can build like a VPN tunnel back to your main corporate site, and everything in the virtual data center can be managed or accessed just like any other remote sites. In this video, we will configure a site-to-site IPSec VPN between a Cisco ASA 1000V and a physical ASA in the VNMC mode. Here's our lab setup. We have a pair of redundant ASA 1000V installed with the Insight VXLAN of 6010, and this is where all of our test VMs are running on. We're going to be building a site-to-site IPSec VPN to a physical firewall on the outside that has the VLAN 602 and the IP subnet of 10.02/24 on the inside of it. And we're going to use the same switch 1 interface that's going to be on the dedicated VRF HQ with the IP of .32 as our ping test IP. So at the end of the configuration, we should have full connectivity between the two environments. So we're going to start off with reviewing some of the config on the physical firewall. So right here we do show interface IP brief. You can see in the outside has the IP of 111.2 and the inside of 10.021. Okay, and if you do show run crypto map, and the firewall has already been pre-configured with the site-to-site IPSec VPN. So here it's the transform set. We got a simple crypto map named VPN. And there's the IP of the ASA 1000V outside interface with the crypto ACL. And if you look at the crypto ACL, it's just allowing all the IP on the subnet 10.02 to talk to a 10.01 subnet. Okay, and it's already enabled on the outside interface. Now on the switch that we're going to use as our ping host, we do show IP VRF. We have the VRF called HQ, and with the interface F1012 tied to it. So if you do show run interface F1012, it's got an IP of 10.02.32 on the VRF HQ. If we do show IP route VRF HQ, you'll see we also have a default route pointing to the inside interface of the physical firewall 10.021. Okay, we can try to do a ping to 10.021 just to make sure it's pingable. Okay, so now let's get on to our VNMC web interface and start our VPN configuration. So we go to the policy management and service policy, and we're going to do this at the app 1 level. Okay, and we're going to be configuring the VPN part of it. First, we're going to take care of the phase 1, just like when you configure a regular ASA. So start off with phase 1 with the IKE policy. So add IKE policy and we'll give it a name as descriptive as we can with the AES-256 SHA with pre-share key. And then we add the policy. We'll leave that as group 2. Encryption we want AES-256. Hash is SHA, authentication is pre-share key, and we're going to leave the default lifetime of 1 day. And click OK. Next, we're going to define a pre-share key for the peer. So that's under peer authentication. Policy. So create one and call tenant1 site. And for the peer device, we want to name it 1112. Just the outside IP of the physical ASA. And for the pre-share key, since we're dealing with IKE v1, just use a symbol key Cisco, and then confirm, and click OK, and then OK. Okay, next we got to create or tie the 2 and 2s together under the VPN device policy. Click on that, and we'll add a name called VPN underscore device and underscore app 1. Okay, so IKE policy is AES-256 SHA pre-share key, and the peer is called tenant1 site. And you can even go deeper as far as the IKE and IPSec settings that's global. So things like if you want to do IPSec over TCP, disconnect notification, let's see what else can we do here. Identity. If you're familiar, you got on the physical ASA, you got IP address, hostname, automatic. We just leave it automatic. If you want to allow NAT transversal and the keep alive for that. And if you're dealing with IKE v2 here, you got some additional configuration that you can do as well. And if you do the TCP port, you can specify the port right there. Same goes with IPsec settings. There's a lifetime, again this is global at the device level for whether it's bytes or the actual time period. Okay, so we're just going to leave those at default and click OK. Now we have to tie our VPN device policy to the edge device profile. So again, what we just did is just pretty much phase one at the global, some of the global configuration. So if you go to the service profile and then app1 edge security profile, or actually edge device profile rather, and we already have one, and if you go edit, policy, and if you recall back in the edge device profile video, we have configured some of these already, and the only item that we left off there is the VPN device policy. Now that we have that configured, we can just select it and apply and OK. Okay, so if you go to the firewall and do a show run crypto, you can see right there the IKE policy for phase one has already been configured, just like how we did on the VNMC. Okay, and you got some IPsec security lifetime as well, which is the default value. Okay, if we do show run tunnel, since we defined a authentication peer already, you can see right here, as well as the pre-share key that's under the tunnel group. All right, so that's pretty much phase one. Now let's move on to phase two. Okay, so for phase two, go back to service policy and IPsec policy. So this is equivalent to a transform set. Call it ESP AES256 SHA, and mode, there's only one mode that's supported, tunnel. ESP encryption is AES256, and authentication we want SHA for that. Click OK. Next we create a crypto map policy. Okay, for the name we call it Tenant1 VPN to HQ. Let's consider the other remote site as like a headquarter, a corporate site of some sort. And then for the rule, let's add the rule. And this is again equivalent to a crypto ACL. For the name, let's call it VPN to HQ. And action would be permit. And you can add the source. And I believe we already have a object group created. So member of app1net, and that includes the whole 10.01/24. So okay, and then for the destination, we're just going to do this by prefix instead of creating an object group. So we know it's going to be 10.020/24. Click OK, then OK, and then we have an IPsec setting right here, and this is a per destination or per peer SA lifetime in seconds or in bytes. Just going to leave those at default. If you want to enable PFS, you can also do so right here, and then you choose the group, and then we need to assign the transform set or IPsec policy to it that we created earlier, and then we specify the peer IP, so 111.2. You can see the logic is pretty much follow when you configure a physical where there is an ASA or a router. As far as phase one, phase two, you just need to know what's the equivalent configuration for that. And if you want to enable NAT transversal, which is checked by default, or even reverse route injection, you can do so. And even whether or not you want to be bidirectional or just answer only or originate only. You can also option to do main mode or aggressive mode. Leave everything at default. We'll click OK. The last thing we need to configure is interface policy. For the name, we'll call it Tenant1 app1 VPN. They will make it enable, and they will move what we have over. And don't forget the domain, and you have to choose whether you want to do IKE v1 or v2. Okay, and for the do not fragment bit, by default will get copied over. All right, and then we click OK. Okay, so just like any other VPN configuration that you do, you need to also configure NAT bypass, so any traffic that needs to get across the tunnel doesn't get NATed. So in order to do this, we'll go back to the NAT section. Actually, let's create an object group first. So policy helper object group, and then we can add an object group. And let's do one called obj HQNet. with the network, IP address, and then prefix 10020, and then subnet mask is /24. Okay, and then we go back to the NAT policies. Now that we have the object group, add a NAT policy. This one is called NAT VPN Bypass, and add the rule. It's called VPN to HQ. So as we just leave it anything, and for the destination, going to be member of object HQNet. So anything that goes towards the 10.02/24 will not be natted if you choose the translated IP of itself. So destination IP pool will make it a self-NAT. Click OK, and then OK again. We'll go back and modify our NAT policy set for the web, and then we add the bypass, and then we'll pretty much bump that up just to make sure that takes precedence, and we'll do the same for the database as well. Bypass, and then go to the top. Okay, now if you go back to the ASA and do show NAT, and you see that SP4 is for database. It's got a static any with the destination static of the VPN to HQ to itself. And you see the same thing down here for the SP3, which is the security profile interface for web. All right, now it's time to do some testing. So from switch 1, we're going to do some ping tests to initiate the tunnel. So switch 1 right here, if you do the ping VRF HQ 10.01.32. Okay, in the firewall we can see show crypto Instagram SA. Looks like it's waiting for a message too. So let's see, make sure we can ping the other side, which is 172.128.16. You can see that's pingable. If you go onto here and then do Instagram SA, now it looks like we just forgot to do one last important step, which is assign the crypto map or the interface policy to the firewall interface. So if you go back to the source profile and then edge security profile, and for the one particularly for the outside, you click edit and VPN. See right here, it hasn't been assigned yet, so we need to choose the tenant 1 app 1 VPN. Click apply and OK. And that's why when the tunnel is trying to come up, there's nothing talking back to it because it's not enabled yet. So let's go back to switch 1. Actually, let me, even before that, let's do one last quick verification, which is show run crypto. You can see right here we have all the crypto map command configured already. Crypto map order 100, and also have that applied to the outside. And right here, IKE v1 is also enabled on the outside as well. So if you're trying to ping again, maybe you have to clear crypto. Let's try ping one more time. And show crypto ASA. You can see it's already active, but somehow we're not getting a reply back. Do IPSec SA. There's decap, there's no endcap. So usually this is like a NAT issue because we know the routing is good. If we do show NAT, let's make sure, let's do a quick connectivity check on the web one, which is sitting behind our ASA 1000V. Let's see if we can at least ping the gateway. Looks like you cannot ping the gateway, so it could be the same issue that we had in the previous video. We just need to reapply the port profile. So again, manage host. Let's go through that real quick. Web 1 is web, web 2 is also the web, and then we have the database here, so database. Give it a couple seconds here for the, okay, there you go, our ping just came back. So now if you hop back onto the switch and trying to ping, there you go, so we get our ping back, ping reply, that means the tunnel should be up. So if you go back to the firewall and do show crypto IPSec SA, we should see both endcap and decap now, which we do. So ping again. Okay, so that's good. Now if you go back to the firewall on this side and do show NAT, we should be seeing some translate hits right here, which we do. This is when the ICMP reply tries to get back into the tunnel. And if we do show crypto IPSec SA on this side, we should now see the encaps packet counts as well. Okay, so now from web 1, we can also try to ping back to 10.02.16. Oh, actually it's 32. There you go. So that's pingable. So sleep that up and running. And we can hop onto the database server. And we can try to ping 10.02.32. You can see it's pingable from the database server as well. And if we keep showing the IPSec SA command, you can see the encap packets keeps incrementing. So at this point, we have successfully built the tunnel between the two ASA, the 1000V to the physical. Now, one last thing I want to point out to you is when we assign the VPN interface policies to the security profile, we have to do that to the outside security profile, which is for the outside interface. So I want to show you what happens if you attempt to assign that to the security profile for the inside interface. So let me take away the VPN. So unassign. So our ping should drop in a second here. You can see right there, it can't ping anymore. But what happens if we assign that VPN interface policy to, for example, the web security profile? So right there, apply, okay. We can also check, although if you jump over here under the resource management, manage resources, and look at the edge firewalls, you can see the config state shows apply. So it looks like everything is all good. But if you come back to the command line and do show run crypto, you can see that all the crypto map command has now disappeared. And we are left only with the phase 1, which is like a global configuration that was applied to the edge device profile. But anything related to the crypto map or the peer or the match or the set statements are all disappear. And it's just because the VPN interface profile can't really be assigned to the security profile for the inside interfaces. Okay, so just one last note that I want to make. So what this means is the host on any security profile can pretty much utilize the VPN tunnel. So the only way for you to kind of restrict what host can access the tunnel is to do it by the ingress ACL to the interface. Or basically you make sure you lock down your crypto ACL. So those are pretty much the options that you have. And this is only because the VPN can only be applied to the outside interface, which is pretty much shared by all of the inside hosts. So that wraps up our video on ASA 1000V LAN-to-LAN IPSec VPN in VNMC mode. Next, we're going to look at how to install and configure the ASA 1000V in ASDM mode using the command line interface. Please visit our website to view an extensive list of our lab videos and sign up to get access to additional lab contents. Thank you for watching LabMinutes.com, and I will see you guys in the next video.